Here's the solution for the mock for differentiation. The diagram shows part of the curve y equals f of x. So they don't give us the equation for the curve, so we can't put it in the calculator. We're just supposed to analyze this curve depending on the questions that they're going to ask us. The first question that they ask us is, for what values of x is f dash of x equal to 0? Remember how I said that a lot of the questions they ask you for this unit require you to remember that the derivative is what again? It's the slope of the tangent of the curve at a certain point, or in other words, it's just the slope, okay? So if I look at this curve, where do I see places where the slope is 0? Okay, that would be, where is the slope flat? So it would be at the maximum point, the minimum point, or this temporarily flat place right there. So I would say it's flat in 3 places, or f dash is 0 in 3 places. It's flat at x equals 3. It's flat at x equals 5. And it's flat at x equals 7. Okay? So those are the 3 places. If you want to say, oh, it's flat from 6.8 to 7.2, you could say that too, but 7's fine. Okay? Next question. For what values of x is f dash of x less than 0? So when does the economy look like it's bad? Whenever the curve is going down, right? So that is a negative slope, that part right there. And that's pretty much it, right? So from 3 to 5, it seems to be, the economy seems to be getting bad, or it's less than 0 or negative. The way I write that with a inequality is 3 is less than x is less than 5, or I could write something like, well, it's not really correct to write 3 is less than or equal to, right? Because we know that at x equals 3, it's not negative, it's actually 0. Okay, so the best answer is what I just wrote there. Okay? All right, let's move on. Differentiate the following function with respect to x. Okay, so remember, the first thing we would like to do is always make sure that when we write the x with the exponent, to make sure that the exponent, oh, look, it's already negative. Isn't that nice? They could have been mean, and they could have written 25 divided by x, and then we would have to rewrite that as 25 to the negative 1, but we don't have to because they already gave it to us that way. Perfect. Okay, so remember, this is the original equation, or the blue equation, and we want to rewrite we want to take the derivative of it because it says to differentiate. Remember, differentiate is just one of several ways to ask us to take the derivative. They could have said, oh, find dy dx. They could have said find y dash. They could have said find f dash of x. They could say differentiate. They could say find the derivative. Okay? Any of those ways. There's probably a couple ways that I'm forgetting too. Okay, so differentiate the following function. And remember, when I take the derivative of 2x, the derivative is just 2. The derivative of negative 9 is just 0. The derivative of negative 25x to the negative 1 is negative 25, and then we bring down the negative 1, and then we have x, and then the negative 1 gets reduced by 1, so it actually becomes negative 2. So I'm going to rewrite the function now. And remember, if I want to put it equal to something, I could say f dash of x equals. It's not correct to say the f of x and then say that's equal to, because this is the derivative. It's not the original function. So I'm going to rewrite this. I'm going to write 2 plus 25, because negative 25 times negative 1 is positive 25, x to the negative 2. Okay, so that's my derivative function. And I'm going to put it right here. I could write y dash equals y dash f dash, same thing, right? x to the negative 2. Okay. Then it says, calculate the x-coordinates of the points on the curve where the gradient of the tangent of the curve is equal to 6. Remember, gradient of the tangent of the curve is just a way of saying slope of the curve. Slope of the curve is talking about the derivative. The derivative is the red function. So first I'm going to turn on my calculator. I'm going to go to y equals, and I'm going to put the blue function into y1, and then I'm going to put the red function into y2. And so I'm going to put 2x minus 9, I'm putting in the original blue function, 25x to the negative 1. And make sure you put negative, this negative, not this negative. Because the other one is a minus sign. That'll give you an error. And the derivative is the red function. It's going to be 2 plus 25x to the negative 2. Okay, now don't look at the graph because that's just confusing, okay? Look at the table when you're analyzing derivatives. And it's going to say, when is the red function equal to 6? Well, let's see. It looks like if I go down a little bit, I'm going to get to some value of 6. And I don't see any red 6 yet. In fact, it's getting smaller, so no, that's not good. I'm going to go back up, okay? Okay. I'm looking for a value of 6. Looks like it would be between 2 and 3, right? So could I maybe like break this down? I'm going to do jump by 0.1s instead. And then I'm going to see if, oh, there you go. So x equals 2.5 gives me a red 6, which means the slope is 6. At what point? So one of the points is going to be 2, comma, or 2.5, comma, negative 14, right? 2.5, comma, negative 14 is one of the points. It says points of the curve, which makes me think there are more points. I'm going to go back to jumping by 1s, and then I'm going to go look for another place. Oh, there we go. Look, there's another place here. Between negative 3 and negative 2, looks like we can also find another red 6, so I'm going to do plus 0.1 again. And look, at negative 2.5, there's also a red 6, so I'm going to write that down too. So negative 2.5, comma, and the other point is negative 2.5, comma, negative 4. So those are 2 points which have tangent, gradient of the tangent, x equal of 6, and I have now found that one of the points is x equals negative 2.5, and the other point would be positive 2.5. They were just asking for the x-coordinates, so I'm putting just the x-coordinates in the answer box. I did find both the x-coordinate and the y-coordinate, because actually I'm going to need it in the next step, because it says find the equation of the normal line to the function at one of the points from B. So they want us to find the normal line at this point or the normal line at this point. Okay? I'm just going to look at the graph really quick just so that you can imagine what it looks like, although you don't need to do this. Before you look at the graph, I would turn off the derivative function by hitting enter at the equal sign and then hitting graph. Okay, and then let's see if I can see anything here. Yeah, there we go. And there we go. Okay, and so basically at x equals 6, which is, or x equals 2.5 comma negative 14, which is down here, that the slope is 6. Okay, now what I'd like to do is to draw, I'm going to make a little sketch of this graph here. So it looks kind of like this, and like this. And so one of the points is here, and the other point is here. At these 2 points, you have a slope of 6. And what we want to do here is we want to draw a normal line coming out of this point at either one of these two, okay? And remember, to write the equation of a normal line, or for the tangent line for that matter, you can always start with the point slope form, which looks like this, and you can find that on the formula sheet. And so you find that off the formula sheet. It basically asks you to fill in the slope and to fill in one known point. And let's start with this point, okay? Let's say we're going to use that point, and we're going to use we're going to draw a normal line through that point, which is this point here. Okay, so our x1 would be 2.5, and our y1 would be negative 14. So I'm going to put y minus negative 14. Oh, I'm sorry, that's an equal sign there. Equals, and then there's a slope, which we'll talk about later, x minus 2.5. So that would be the equation of my line. I just need the slope. Well, the slope we know is related to a slope of 6 because we know that these 2 points have slopes of 6, but we want the normal line, and the normal line is perpendicular to 6. Remember, to find the perpendicular to a slope of 6, we do the negative 1 over the slope. So our m value is going to be negative 1/6. So there is my equation right there. If I wanted to simplify it, I could write y plus 14 equals negative 1/6 times x minus 2.5 in parentheses. Now if I wanted to do the other point, remember I could do the point negative 2.5 comma negative 4. It would look similar. I would do y minus negative 4 equals, and I would put negative 1/6 for that slope too, and then negative 2.5 here. And if I wanted to simplify that, it would be y plus 4 equals negative 1/6 times x plus 2.5. So you could answer with either that or with that. Okay. Last problem. Okay, and this is an optimization problem. Let's see, a rectangular piece of card measuring 24 by 9, that we drew it right here. Each square of length x are cut from each corner of the card as shown in the diagram below. What is left is folded to make an open box of length L and width W. Okay. So if I took this paper and I folded up the edges at the red and the blue lines, it would look kind of like this. Okay, and then oops. And then the heights, I'm going to draw in black. So basically I folded up all the edges, and then you could see that the red edge is like the width, and the blue edge is like the length of the resulting box, right? And now let's go down and answer some of the questions, okay? Alright, so write an expression in terms of x for the length. Okay, so let's say that the length is blue. So the length in terms of x. So let's see. I'm going to relate x, 24, and the blue length. Okay? So this will be length, and this will be width. So the length is related to 24 and x by the fact that if I add L plus x, I get 24, right? So if I wanted to write the length in terms of x, I could do length equals 24 minus x, or length equals 24 minus 2x. Okay? What about the width? How could I write the width in terms of x and 9? I could say that 9 is equal to the width plus x. So that would be 9 equals w plus 2x, or w is equal to 9 minus 2x. Okay, so those are my two expressions that part A was asking for. Part B says, show that the volume B of the box is given by this equation here. Now remember, whenever they say show that in an IB exam, they're trying to actually give you a challenging problem, but not make it impossible to do the rest of the problem. So the fact that they said show that B equals that means that from this point on, you can use this expression for parts C and D, even if you can't do part B, which is quite challenging. Okay, so let's pretend that, first of all, that we could not do part B. And let's say, okay, well, I couldn't do part B, but it says to show that this, so this is true, and I'm going to use this result for my next step. So the next step says, find the derivative, because this is, remember, dy dx is the derivative of y, dB dx is the derivative of b. So if I want to find the derivative of this blue equation here, and let's see, so I'm going to write it here. I'm going to write it in blue. So b is equal to 4x cubed minus 66x squared plus 216x. I'm going to take the derivative of this and write it in red, so b dash or dB dx, either way. 4 times 3, which is 12, x squared minus 66 times 2x plus 216 with no x, right? And I'm going to write that in the box here. I'm going to write 12x squared minus 66 times 2 is 132x plus 216. So that's my answer for dB dx. Okay, dB dx is b dash. Last one. Find the value of x, which gives the maximum volume of the box. Calculate the maximum volume of the box. Okay, so basically now all we need to do is to graph the blue function in the calculator and to find what the maximum point of that is. Now be careful, don't graph the red function. If you graph the red function, the x value should be when the derivative function is equal to 0, because remember, the derivative of the slope of the function is 0. Those are the points that are maximum minimums. That's what we're looking for. But remember, when you have the calculator to solve these optimization problems, you don't have to use the derivative. They ask you to find the derivative because that is a math concept they would like you to understand. But when they ask you to find the x which maximizes or minimizes it, all you need to do is use the calculator. Okay, so let's turn the calculator on. Okay, go to y equals, and I'm going to type in the blue equation only for now. And then I'll type in the red equation later so we can see that actually at the maximum point it's actually equal to 0. 4x cubed minus 66x plus 216x. Oops, it's actually 66x squared, isn't it? 66x. So I'm going to do second insert squared. 216x. Okay, and then I'm going to graph it, and it's going to be this huge thing that probably doesn't even show up on my screen. I need to adjust my window. Oh, look at it. So I'm going to do a second, or I'm going to do like a zoom fit, okay? Zoom fit, which is I think like option 0. There we go. It shows all this negative area, which we don't care about, right? We don't care about negatives when we're doing a problem about volume, right? So let's adjust the window a little bit. Instead of, look at this. The y min value is negative 12,000. I don't think we need negative 12,000. Let's make it like negative 1 instead. Okay. Now let's graph it again. We want to know the maximum value. So there it is right there. Let's see what it is by doing second calc max, which is option 4. And the left bound, we'll leave it there, and then the right bound, could I just type in a number? I don't know. Can I just type in 9 or something? 9. No, I can't. I never did that before. Guess. Yeah, it doesn't matter what. So the maximum value is x equals 2, y equals 200. So it says 2.000012, but if you round that to 3 significant figures, you're going to get 2.00. And remember, the calculator is not good at math concepts. It is not doing the derivative here and finding the actual theoretical answer. It is like trying a billion numbers, and the number that gets close is 2.000012. That's not the real answer, okay? You have to be smart enough to know that and say, oh, the answer is actually 2.00, which is actually 2, okay? So my answer is 2, and the maximum volume of the box is my y value, which is 200, right? Because I just graphed the b value, and so the y value corresponds to the b value, right? Okay, and I just want to show you what the red function is at that point, just so that you can see that there is meaning to this. So I'm going to put 12x squared minus 132x plus 216. And then I'm going to look at the table only. I'm not going to look at the graph because that's confusing to look at these graphs. And look, what do you know? At 2,200, the red value is 0 because that's a maximum. Now you see down here, there's also another 0. That's probably the minimum point. But negative 486 is not a valid volume, so we just ignore that. Okay. So that's part C. Let's go back and do part B now. Okay, I just wanted to show you that you don't have to be able to do part B to do part C. So don't just give up or reflect on your mock exam and say, oh, I couldn't do part C and D because I didn't know how to do part B. I will immediately give you a 0 on the reflection there because you did not listen to the video. Show that the volume B of the box is given by this function. And so basically, we know that volume is always, for a rectangular prism, is always length times width times height, right? And we already have expressions for length and width. We just don't have an expression for height. But remember, this black line here is x. So we actually do have an expression for height. So first we're going to write that L is 24 minus 2x. Then W is 9 minus 2x, and then H is actually just x, right? And then I'm just going to do some algebra. I'm going to do FOIL. I'm going to expand these two binomials by doing FOIL. 9 times 24, I don't know what that is, so I'm going to do that on the calculator. It's 216, so the first term is going to be these two multiplied together. It's 216. The last term is going to be negative 2x times negative 2x, which is plus 4x squared. If you don't know how to do FOIL, come talk to me at Homework Club. If I want the middle outside and inside terms, I would do negative 2x times 9 and negative 2x times 24. That would give me negative 18x for the inside term, negative 48x for the outside term. That I'm getting closer, okay? So if I combine negative 18 with negative 48, I get negative 66. So now I'm down to 216 minus 66x plus 4x squared. And now I'm going to multiply that times x. I'm going to distribute the x, so I get 216x minus 66x squared plus 4x cubed. And now you can see I got the exact expression here, except it's reversed, which is fine. And so actually your answer here is not this, because this is what they already gave you, right? Your answer here is these steps. So step 1, I used volume equals length times width times height. Step 2, I substituted in the expressions from A. Step 3, I did FOIL. Step 4, I distributed the X to each one of the terms that I got from FOIL, and then I finally got the answer. Okay, so that's what we're expecting to see for part B. I know it's really difficult. I know that if you're bad at algebra, you're not going to get this part, but that's okay. These are for, you know, if you're going for a 6 or 7, you definitely want to have good enough algebra to get these sections of the problem on the exam. Okay, so that's it for the solutions to differentiation.